So in this video, we'll see Refactor Life, a solution, but in a functional way. So in my previous video, I've done a basic solution. I mean, I did the Refactor Life, but it was a bit of class based and not much of a change. Now I took a little inspiration from other submissions and refactored it to a bunch of pure functions and little side effects. Little side effects being displaying the grid. And we'll take a look at the code. I'm not gonna be doing a live coding, but some time ago I did the code, and we'll look at that. So here it is. So the run game is where the entry point is, and it takes width, height, and the iterations. So before even that, let me run the code. So life func is the current code, functional. So it runs. Let's go to the code. Make grid is a pure function. It gives you the data for the grid, and you can pass your length and breadth, and it gives you the grid. Simple function. So that's the grid. And there's a separate function that randomizes the grid, and you can also pass a probability. Let me just go to its definition. So here it is. So it randomizes the grid based on the probability. So here's a default value 0.3. You can modify that, and also it's random. If you want like deterministic, you can set the seed. And that's this function. So it does not modifies the original grid, but instead returns you the whole new grid. And I'm mutating the same state grid, and I'm just randomizing it and mutating it. And then it runs the grid with these number of iterations. Now let's go into that function. So it clears that, and this is for Windows, we don't need that. So it displays the grid. So let's look at the display. Displays a pure function with little side effects. Yeah, it's not a pure function, it's a side effecty function. So it prints to the console based on the grid value. Then a step is done. This is the new step, or maybe the new state of the whole grid. So it takes the previous grid and it returns the whole new grid. It doesn't really modify the old grid, but instead I'm modifying the state myself. And then it sleeps for certain delay, and delay is configurable, and it sleeps for 0.1 seconds. Let's go to the step. So this is just deriving a few values and new grid. So it's gonna call the same function make grid, where the new grid is made, and it applies the rule and sets that state to that specific that specific cell, and it returns the new grid. Now let's jump into apply rules. So it gets the state of the cell, takes the grid, and the count neighbors. Let's dive into that later. Applies the rule and gives that rule, right? And let's go to count neighbors. So again, it's a pure function. It returns the count. It doesn't do anything. It takes the grid and x comma y, the cell coordinates, and it counts the cell neighbors around that cell. And then there is if cell alive, so it's just a simple utility function that just returns the value. It's like an identity function, but it looks nice while saying if cell alive. It's just a boolean expression if the value of the cell is not falsy. And pretty much that's it. So all this is in, and maybe I'll set the random seed to some value, random dot seed. Okay, 42 it is. Uh, yeah, so it's end up in the new same state over and over again, and this is life with a functional way of doing things. Thank you.